Okay, this is chapter 5, and this is a live recording class for soil dynamics. This is on dynamic soil properties. So content is, we'll see some introduction, and then field tests, geophysical tests, which are either low or high strain field tests, and also laboratory tests with low and high strain lab tests. And finally, you'll see the strain behavior of cyclically loaded soils, which are usually either shear modulus and damping curves. The last part, stress strain behavior, especially the shear modulus and damping curves, they are automatically input to a finite element model or a dynamic analysis using either FLAC, Flaxis, or other softwares. So similar to like a static analysis, we need an input for a dynamic analysis of geotechnical structures with the soil. Those properties are important whether you analyze it can be a dam or a building with the soil or anything. We're using softwares. Those properties are mainly something like shear wave velocities and P wave velocities or the shear modulus. Similar to like a static shear modulus, we have strain dependent shear modulus, which is it's not a constant like static, but it depends on strain. And also the damping curves. So the dynamic proper soil can be obtained from field, like geophysical tests. You can go out in the field and do some tests. There are low strain tests. When you say low strain, it's about strain less than 1 raised minus 3 or 0.001. Something like a wave propagation or seismic tests are what we usually get for low strain. Or it can be a high strain test, which is larger strain. And from field tests, it can be like, correlations with SPT and CPT tests. Tests like standard penetration test, compenetration test. You can do it like for a static case, but for a dynamic case, we can have those relations, and they are high strain tests. High strain is when you disturb the soil. You create large deformations, and that's what we call high strain. Low strain is the wave passes through the soil, but it doesn't do that much deformation in the soil. We can get those soil properties also from a lab test and from something like a resonant column test. We'll see the detail of it. It's a low strain test. And for high strain test, we can say cyclic track gel test, cyclic simple shear test, check table test, and centrifuge tests. You already know from your static test, track gel test, or direct shear test or simple shear test. But when we apply a cyclic load on those, that's how we get the dynamic properties. And we can have also a check table test in the lab. It's like it can be a full scale or a small scale or a centrifuge tests. So when we go to field tests or geophysical tests, we usually do these tests if we don't want to disturb the soil or the natural soil. We just apply some wave or some kind of radar passing through the soil and record it at some point and try to interpret the result out of it. Something like a sinkhole. Sinkhole, if you see this, these are sinkholes. These are voids underground. And these voids usually come from, like, if you have a limestone deposit, the soil particles can be washed away. And what you get is just a void underground. And these voids, usually they may not be visible. So some people may try to construct buildings at the ground surface, but at some point it may collapse because it's a void underneath. So a voids like this can be obtained or can be diagnosed using seismic tests or radar tests. So that's what we call geophysical tests. And something like this can lead to a collapse. For example, under a highway, you have this void, it wasn't visible, then at some point, all of a sudden, it just collapsed. Or you can see this This asphalt is like a sign of some void, some depression underneath. You see the cracks and the ground going down. This telling you something is going on underneath. And you can do geophysical tests, seismic tests to identify what's going on. Because this in Ethiopia, I don't know if we have something like this. Is it common here? I doubt it, right? But in US, especially in Florida, it's very common because they have a limestone deposit underneath, and there are houses which are swallowed entirely. There are people dying because they don't know what's underneath really. This can be at some depths also. Initially it can be at some depths, and when they build the house, they don't see it. Then through time, it gets worse. The void grow up and everything collapse. There are pupils sleeping in their house swallowed. So this is common in US, especially in Florida state. In Ethiopia, there may be rare cases here also, but it's not that common. So for these geophysical tests or field tests, we can do seismic refraction test. It's using the refraction property of the wave, or seismic reflection test, or MSW, multi-channel analysis of surface waves. This is also seismic test. And SASW, surface analysis of spectral analysis of surface waves. Or we can use ground penetrating radar. These ones are for different applications. Usually borehole geophysics we can use for seismic testing. We can do a borehole on one side, another borehole on one side, and send a wave between the two and record it. We have a wave source at some point here, and we receive it at other point right here. And based on this propagation property of this wave, then we can tell what's inside. And ground radar, penetrating radar, magnetometric surveys, electrical resistivity, and ground conductivity. They are also geophysical tests, but we may not use them mostly for geotechnical engineering, but in the mining activity, when they try to investigate if the presence of some kind of mineral, gold, or other resources, they use this kind of techniques. So we may not focus on these ones for geotechnical engineering, but we'll see some detail for seismic reflection, refraction, and MSW, SSW, and also the borehole techniques together with the seismic waves. In the seismic field tests, so we have reflection, seismic refraction, SSW, MSW, and borehole methods. And the general technique is, let's say you apply a source, you hit the ground with a hammer, or you can do some kind of explosion. So what this does is it creates wave. There is a wave passing along the ground surface. And if you see this instruments, they can be accelerometers recording the wave. Or usually they use geophones. Geophones is something similar to accelerometers, but the best part of geophone, you can use it far away from cities where you don't have electricity. It doesn't require electricity to use it. So you record it. Whether you use geophones or accelerometers, you record the wave. And you have a series of these geophones. You see one here, 2, 3, 4, and many of them. Or you can have like a 3D along the surface in any direction, like in a multi-channel way. So once you apply a source, that wave passes through the surface, and also the wave goes down. So there are two ways this wave go. So let's say this is the ground surface, you apply a source here, and there is a direct wave going at the ground surface, and there is also waves going down. And if you have layers, multiple layers like this, waves reflect at each layer and refract, they go down. So what this does is this wave comes back, it travels underground, it travels across the surface, and you have your receivers at different distance. So you record the wave. You know the time you introduce the source. You know the time when it arrived to a source. There are equipment analyzing Because if you see the hammer right here, this guy is hitting the ground. The hammer is connected to you see this wire. This wire is going to the computer. It's recording when the actual hit is happening. Then, if you know the time it's initiated, and also you know the time they are recorded, so you know that how much time it takes. So that's the general philosophy. Even if they are using different techniques, in the reflection technique, we are focusing on the waves reflecting at each interface. In the refraction technique, seismic refraction, because you may have multiple layers, waves pass from one layer to the other layer, and they refract and they reflect. So we are recording those. And SSW and MSW, it's depending on the